Hello students, welcome to Tejakshar Academy YouTube channel. In this session, I am going to discuss heat transfer problems on thermal conduction part 6. If you like this video, please subscribe to our channel. Please share your valuable comments in the comment section. Okay, let us go to the today's session. First one. The thickness of ice in a lake is 5 centimeters and the atmospheric temperature is 10 degrees centigrade. Calculate the time required for the thickness of ice to grow to 7 centimeters. Thermal conductivity of ice is 0.004 calorie per centimeter second Kelvin. Density of ice is 0.92 gram per cubic centimeter and latent heat of fusion of ice is 80 calorie per gram. Now, in this question, we have to calculate the required time for the thickness of ice to grow to 7 centimeter. Now, let us go to the solution. In this question, the given here thickness of ice in a lake is 5 centimeter. So, x1 is equals to 5 centimeter and x2 is equals to 7 centimeter and theta they given as 10 degree centigrade and its thermal conductivity K is equals to 0.004 calorie per centimeter second Kelvin and they given as the density of ice is 0.92 gram per cubic centimeter and we have to calculate the change in temperature. We have to calculate the required time. Delta T is equals to T2 minus T1 and they given as latent heat of fusion of ice L is equals to 80 calorie per gram. Now delta T is equals to rho L by 2k theta of x2 square minus x1 square. Now substituting values in this we get delta T is equals to, now substituting values, rho nothing but 0.92 into 80 by 2 into 0.004 into 10 of x2 square minus x1 square, that is 7 square minus 5 square. So delta T is equals to 9.2 into, here this 0 get cancels, 8 by 2 into this 0.004 can be written as 4 into 10 to the power of minus 3 and 2 ones, 2 4s are 8, 4 gets cancels, here 7 square 49, 5 square 25. So that is equals to 9.2 into 49 minus 25, 24. 24 by here 10 to the power of minus 3 into here 10 to the power of minus 2. So 9.2 into 24 into here 10 to the power of minus 3. So that is equals to here 10. 0.92 into 80 can be written as 9.2. So here this 80 and 10, here 10 to the power of minus 3, 10 to the power of minus 3 plus 1 minus 2. that is equals to 9.2 into 24 into 10 square. So that is equals to 220.8 into 10 square. So this can be written as 22080 seconds. So total required time, that is equals to 22080 by 3600 hours. So that is equals to 6 hours. Okay, required time is equals to 6 hours. Now we will go to the next question. Water in a lake is changing into ice at 0 degrees centigrade. When the atmospheric temperature is minus 10 degrees centigrade, the time taken for 1 centimeter thick ice layer to be formed is 7 hours. Then time required for the thickness of ice to increase from 1 centimeter to 2 centimeter is. Now let us go to the solution. Given x1 is equals to 1 centimeter and x2 is equals to 2 centimeter and t1 is equals to, they given as 7 hours, we have to calculate delta t. T1 is directly proportional to x1 square and delta t is directly proportional to x2 square minus x1 square. So this can be written as delta t by t1 is equals to x2 square minus x1 square by x1 square. Now substituting value, then we get delta t by 7, that is equals to 4 minus 1 by 1. 4 minus 1, 3. So delta t is equals to 7 3s are 21 hours. So delta t is greater than 14 hours. Okay. Next we will go to the next question. A pond has an ice layer of thickness 3 centimeters. If K of ice is 0.005 centigram seconds units, surface temperature of surroundings is minus 20 degrees centigrade. Density of ice is 0.9 gram per cubic centimeter. The time taken for the thickness of ice to increase by 1 centimeter is. Now let us go to the solution. Given x1 is equals to 3 centimeter and here density of ice rho they given as 0.9 gram per cc and conductivity they given as K is equal to 0.005. This is CGS units. So this can be written as 5 into 10 to the power of minus 3 CGS unit. So theta is equals to, they given as 20 degrees centigrade and x2 is equals to 3 plus 1, that is equals to 4 centimeter and latent heat of ice they given as here 80 calorie per gram. Now we have to calculate required time. So delta t is equals to T2 minus T1, that is equals to rho L by 2k theta of x2 square minus x1 square. Now substituting values, then we get rho nothing but 0.9, L 80 by 2 into 5 into 10 to the power of minus 3 into theta 20 of 4 square minus 3 square. Next, delta t is equals to 0.9 into 80 can be written as 9 into 8 by 2 5s are 10. 10 into 10 to the power of minus 3 into 2 into 10. 20 can be written as 2 into 10. 4 square 16, 3 square 9. So this here 2 ones, 2 fours. 9 4 ja 36 into 7, 16 minus 9 7 into 10 to the power of here 10, here 10, 10 square, 2 minus 3 1, so reciprocal 10 to the power of 1, so that is equals to 36 into 7 into 10, so 36 into 7 into 10, that is equals to 360 into 7, that is 2520 seconds. So required time delta t is equals to 2520 by 60 minutes. So that is equals to total required time 42 minutes. Okay, so therefore delta t is equals to 42 minutes. Okay, next we will go to the next question. If air temperature remains constant at minus 20 degrees centigrade, find the increase in thickness of ice layer on a pond between 7 pm to 7 am. Next day, if the initial thickness at 7 pm was 10 centimeter for ice, L is equals to 80 calorie per gram and its thermal conductivity K is equal to 0.005 Ccs units and density that is equals to 0.917 gram per centimeter or cubic centimeters. Now let us go to the solution. Given theta is equals to 20 degrees centigrade and its conductivity they are given as 0.005. This can be written as 5 into 10 to the power of minus 3 Cgs unit. Cgs units and latent heat of ice L 80 calorie per gram and x1 they given as 10 centimeter and rho density they given as 0.917 gram per cc. X2 minus x1 we have to calculate and the required time delta is equals to 12 hours, that is equals to 12 into 3600 seconds. T is directly proportional to x square. So delta T is equals to rho L by 2k theta of x2 square minus x1 square. Now this can be written as x2 square minus x1 square is equals to delta T of 2k theta by rho into L. So here from this x2 square is equals to delta L 2k theta by rho L plus x1 square. So this x2 is equals to under root of delta L 2k theta by rho L plus x1 square. Now substituting values, x2 is equals to under root of 12 into this is delta T. Delta T nothing but 12 into 3600 into 2 into its conductivity value 5 into 10 to the power of minus 3 and theta 20 degrees centigrade and rho 0.917 into 80 plus 10 square. So x2 is equals to here 0 0 0 and here this 0 total cancel and under root of 12 into 36 into here 20 by 0.917 into 80. 0 0 gets cancels, 2 1s 2 4s and 4 1s 4 9s plus 10 square nothing but 100. So now next x2 is equals to square root of 108, 12 nines are 108, 108 by 0.917 plus 100. This is x2. Next x2 can be written as x2 is equals to square root of 108 by 0.917 can be written as 117.7 plus 100. So x2 is equals to square root of 217.7. This root of 217.7 it gives 14.76 centimeters. So increase in thickness of ice, that is increase in thickness of ice, x2 minus x1 is equals to 14.76 minus 14, that is equals to 14.76 minus 76, that is here 0.76 centimeter. Okay, here increase in thickness of ice, x2 minus x1 is equals to x2 nothing but 14.76 minus 14, that is equals to 0.76 centimeters. This is the increase in thickness of ice. Okay, next we will go to the next question. In engine hose experiment, the wax melts up to 5 centimeter and 10 centimeters on bars A and B respectively. The ratio of the thermal conductivities of A and B is, here we have to calculate the ratio of thermal conductivities. Let us go to the solution. In engine hose experiment, in engine hose experiment, ratio of thermal conductivity is K1 is to K2 is equals to L1 square is to L2 square, that is equals to 5 square is to 10 square, that is equals to 25 is to 100. So K1 is to K2 is equals to 1 is to 4, 25 ones, 25 fours. So the ratio of thermal conductivities are K1 is to K2 is equals to 1 is to 4. Okay. Next we will go to the next question. Next one. A rod of length L with sides fully insulated is made of a material whose thermal conductivity K varies with temperature as K is equals to alpha by T, where alpha is constant. The ends are at temperatures T1 and T2. T2 is greater than T1. Find the rate of heat flow in the rod. In this question, we have to calculate the rate of heat flow in the rod. Now, let us go to the solution. K is equals to alpha by T. Rate of heat flow H is equals to rate of heat flow H is equals to minus integration of T1 to T2 K A by L into dt. So this is equals to minus integration of T1 to T2 alpha by T into A dt by L. Next, h is equals to minus integration of t1 to t2 k nothing but alpha by t of a dt by L. So that is equals to minus alpha a by L integration of T1 to T2 integration of T1 to T2 dt by T. So that is equals to minus alpha a by L of ln into T integration of dt T1 to T2. So that is equals to minus alpha a by L into log T2 minus log T1. So that is equals to minus alpha a by 2 of ln into T1 by ln into T2 log T1 minus log T2. So h is equals to minus alpha a by L. This is alpha a by L into ln of T1 by T2 log of T1 by T2. Okay. Thanks for watching this video.